Hello, I'm about to present a program that is made for ultrametric decomposition of the embedding. First, I'm gonna show what it is doing right now and what it is able to do, and then how it works. So, let's say we write some tokens like toward evil creatures, cat, dog, fish, hands, and we're gonna see how they align. So here I have two working functions, of course save output, which is interesting for us, and Ron's question. He was asking about the level, so we see it saved reports, and we go to the current phrase and report with a timestamp. Here is our report. It is showing us a very short version of extraction of those tokens. So 17 is a common semantic. If we get to 15, it means that token is very noisy, so it is not very precise defined in the language at all, because it is embedding, and this clustering is made on the whole embedding. So it is about our language. It is nothing precise. Fish, for example, is not a leaf. Fish doesn't mean anything specific, and of course, if anybody thinks about it, it is a category of creatures. So yeah, hence, as we see, as many old words have very specific co-occurrence in texts, and they are in very dense layers. They doesn't lead to anything specific, anything ambiguous in context. So those words have a very high level, and they foil the answer of the any model by cutting lot of paths that are leading to other words. So because it is always next token guess. So though have high correlation, though have a very low. And not a leaf mean like guess what fish we were talking about a shark or something small or whatever, yeah, or prehistorical fishes and so on. And because this is just the report as generalization, here we have now list every token we have used. So for example, art, where it exists in the category, so we can open such a category. Let's try, for example, this one, so I can list them directly and see what is there. So this is our category, and we can see that our words art as MCP glamorize Japara. Probably these words here exclusive. They are exclusive, so they fall in the category for first time on this level 18, and it tells us how the transformer was finding concurrence in embedding. So which words were often shown with word art, or all of them together. If we go further, so we can see in our report that, for example, hands is high category. Probably there be not many words there. And in this category, we have hands current, quite common use. And if we go further, because it doesn't tell us much, so where was our hands? Where was our hands? See again how it falls low. It falls low to 5, but let's check some category around quite normal language, so it will be 20 to 12, yeah, it could be. Let's see how these words connect to the other words. And what is the most common language use? Description means hence current. So this word is quite often used in definitions, and every human being can consider it reasonable. It is how our language works. So in ultrametric, we see in which concurrence is connected to cosine similarity and Euclidean distance. So any model you ask where there is no hug in the face doesn't know where it knows this word, and there is no other mathematical tool that can find it, but they can find the nearest words. However, we can search how it leads to the words in cosine similarity and Euclid distance, so we can track the words and see in those other words. Those are tokens, and those are just hiding vectors, which are listed here. How it happens that cosine similarity and Euclidean distance consist of the vectors we have there, so tokens. So why language is connected that way? And here quite often we can find funny stuff. Why people connect words, like authors or specific words from the texts, or in most cases we can find here words leading to some areas like economic, historian, crimes, or some newspapers authors or websites. Quite often, if we search for some medicine, it will be quite often in ultrametric description we would find some sites about medicines. So it is quite common. And what this tool does, so now summary, because this is what is the result readable to human at the first glance. But this tool can take the whole embedding, and you just need to choose how many vectors it consists of. And it's making kind of unzip. So from 1 gigabyte you're gonna get about 100 gigabytes of data. So I have a separate hard disk for that, like this. And this hard disk is only for this one program. So here I have unpacked Glow 300D, so vectors of 300, and listed it. It is taking long time to unzip that way, and the whole description of ultrametric tool you have here in the papers. So you can go to the data entrapment labs, so entrapment.com, and here is hierarchical metric flow and data graph, appendix, which is used, and appendix 2, which is not used now, but I'm about to implement later. And here is more operation you can perform on the embedding. On one CPU and one hard disk it could take months, so it is not easy one. Lot of math. And here you can paste words, ultrametric addresses, or codes which exist in the tokens, as we see in here, and extract information. Those information gonna tell you if the phrase you have organized have any meaning, and here you can list what meaning it could have for other people. So what is the most common if you doesn't use foliation. However, if you add other words to context, so the next tool gonna cross checks the tokens you have used and see how they gonna collapse to given words, so what they have a meaning in context. And that's the tool that analyzing language. If you expect that language is a graph, or something like that, it ends up somewhere on the level 12, and then there is a quagmire swamp. Most of the tokens refer to instincts, behaviors, emotions, and similar things. And logically, evolutionary based language cannot base on academical science of how it should be constructed. No, language is used by the humans, and embeddings are just a reflection of that, how we are using language and for what, and whatever we like it or not, it is our mirror. And for agentic AI use, it is quite important that if we tell something, like we write some commands to agent, words like rules, policy would not work because they are semantically degenerated. Because there is many texts on exception where rules doesn't apply. There is a lot of documents from codes, a lot of laws, how you can skip such a rule, and so if you want to use some words that have a high ultramatic value on agents, you need to search for words that refer to rules where there is no discussion about the rules, how you can omit them. So any text that use like Old English or Latin and is referring to religious scripts, so there is no discussion to break the God laws, would work. And the reason for that is because there is no texts leading towards that allow to skip the rule. So there is no chain of thought that allow agent to process and break the rule. If you write the policy can be skipped very easily. There is a lot of texts about skipping policy, when they apply, when they don't apply, and so on. And all the model have in the chain of thought is just our texts, nothing more. So if we can use language to exception from the rule, it is able to do this. However, there are some languages that currently doesn't work for models because last years they were used for breaking them, like Venian Chinese, classic Chinese, were used as a vector of attack, and currently all Venians are classified by embeddings as vectors of attack, and if model detects Venian, first reaction is leading to clusters that it is some jailbreak or exploit or something like this. So Venian doesn't work any longer. And if you start using Latin and someone write text how to skip your Latin phrase, so there'll be more and more texts that gonna disintegrate how we understand language, or at least how in embedding it is understandable. So the next context to make a precise command will be longer and longer and longer with higher correlation until in embeddings the language gonna change into the Zoop. So this is things I'm working on, and I'm using prototyping tool to get this, and I'm mostly based on math, so for now I didn't make tokenizer or something like that. I'm just working with those databases to extract data. Thank you.